we get a couple of questions pretty frequently about VPD, starting off with what's the VPD I should be running in veg? And that's always going to depend on your facility and your growth characteristics a little bit. But the general rule that I usually use is start off with a VPD around 0.9 to 1.0. And this kind of puts you in a sweet spot for small plants that don't have a lot of root mass, where there's enough transpiration going on that they're getting water and nutrients pulled up from the root zone, but not so much that they're losing more water through the leaves than they can replenish from the roots themselves. So if you start in that range and see how the plants respond, you can dial it in either up or down a little bit. But that's a pretty good starting range, right around 0.9 to 1. I like to run my rooms pretty warm in veg for really taking advantage of max photosynthetic rate. So if you have really healthy plants with good momentum and vigor, you can run the room at 85 degrees day and night. And to achieve that 0.9 to 1.0 VPD at that stage, you're going to need to keep the humidity around 78%, which is quite high. So anybody's going to have to keep in mind that if their temperature is lower than that, they're going to have to reduce their humidity pretty significantly. And I certainly wouldn't recommend keeping this humidity and VPD or the temperature throughout the whole cycle. This is just for veg. And one of the other questions we get that relates to heat and VPD is whether we should measure leaf surface temperatures when calculating VPD and comparing it to the ambient air temperature, or if we should just use the ambient air temperature for the calculation and assume that the leaf temperature is the same. My opinion here is that the best option is to actually just use the ambient air temperature and assume it's the same as the leaf temperature on average. And the reason for this is because I've done a lot of leaf surface temperatures in different facilities and different positions. And what you'll find if you run around with a little IR thermometer pointing it at leaves, you'll find huge variation across the room. You'll have some at the top of the canopy, some at the bottom of the canopy, some on the outside, some under a light, some in between lights. And what that means is you'll have no consistent number for a leaf surface temperature to use. It'll be so variable, you're all over the place. So in order to simplify that, my strategy is to assume that the ambient temperature in the room is pretty close to the average leaf surface temperature across the plant at different canopy heights and throughout the room, and then just use that for the VPD calculation. And I think that works pretty well. If you have really amazing airflow and a low enough plant density that all of the leaves are exactly the same temperature, then you could get a little more precise. But in general, I don't see facilities where there's enough uniformity for that to usually work. Going into the first 3 weeks of flower, a lot of people are wondering what the humidity should be. And I'm going to sound a little like a broken record here, but the humidity should always be in proportion to your temperature, informed by what you want your VPD to be. So during this stage, I'm usually shooting for a VPD of around 1 to 1.2, both day and night. And what that means for my facilities is that I'll be running the daytime temperature around 84, 85 degrees, which means that my humidity is going to need to be around 73 to 75% to hit that 1.0 to 1.2 range. And then at nighttime, I might keep my temperature at 80 degrees and the humidity I'm aiming for is around 68 to 70% to be in that range. So one of the things you might have noticed if you run a sealed room and you have your CO2 run out is that the humidity will spike up really high. And that's a really consistent pattern that just has to do with plant physiology. So what's happening is the plant stomata, its pores where it does gas exchange, lets CO2 in, they open and close in proportion to how much the CO2 concentration is in the air around them. So if there's a lot of CO2, then the stomata don't have to be fully wide open. They can just sit at some partial opening and still get plenty of CO2 in. That partial opening also means that they're not releasing as much water vapor, humidity into the air. So what happens when your CO2 runs out in a sealed room and say it drops from 1200 ppm down to 300 or 200, the plants sense this, that they're getting far less gas exchange and CO2 absorption. And the plant thinks, well, I have to open up the stomata much, much wider to be able to get enough CO2 to keep photosynthesizing. And what happens is the stomata go to full opening, and then you've got water vapor that's freely entering the air. So water's just getting sucked through the plant at a really high rate. And you'll see the amount of vapor can actually cause significant changes in your environmental metrics, especially if you're running close to your capacity for dehumidification. So like a lot of rooms, if you were already kind of running like right up on the edge of your total dehum capacity, and then the CO2 runs out and the plants start dumping humidity into the air as the stomata open up, the dehumidifiers can no longer maintain your set point, and you'll see these huge spikes in humidity. This is a really common thing. And if you have the right data where you can graph CO2 and humidity on the same chart, you'll watch it happen. As the CO2 drops off, your humidity just shoots up like a rocket. Well, I think one of the really useful things about looking at your plants every day and comparing what you're seeing to the data on a chart from your environmental sensors is you start to get a sense for how plant posture on a hour-to-hour basis really can be reflected in the data that you see in a chart, and especially for VPD data and temperature data. And you might go into your room at one point in the day and see plants that are very perky. They're praying, the leaves are up, everything looks really happy. And you might go into your rooms on another day or another time in the day when the environment's really different and see everything's a little bit more curled over. And there can be a lot of factors that relate to this, especially early on total light accumulation. But the environmental factors are really key here: VPD, temperature, and humidity. And it's really useful to get a sort of sense for plant posture and what it can tell you. Taking the posture of a plant and letting it be a piece of information that tells you about what physiology is happening inside the plant, and then thinking about how your environmental strategy is relating to this and seeing how it all connects together. So once you start to get the data and you can kind of close these feedback loops where you get to look at the plants, look at the data, look again, see the changes, you really get a sense for what the plant's telling you as it changes its position. It's like its own sort of sign language. So in veg, for example, plants are particularly sensitive to environmental conditions because they don't have a large root mass yet. So you can really notice these changes in plant posture very clearly as the humidity and the VPD fluctuate. And a lot of people ask us about what is the best humidity that you can have in veg. I like talking about plant posture because it's like actually one of the best metrics for just like how are your plants doing on a day-to-day basis. And I don't hear people talk about it enough. So how do you handle the VPD after the first 3 weeks of flower? It's really pretty simple. I prefer to run basically equivalent daytime and nighttime VPD levels, but different day and night temperature levels. So as you progress through flower, your temperature levels are going to drop, and the amount of difference between day and night is going to increase. So if you started off in weeks 1 through 3 at 85 degrees during the day and 80 degrees at night, then you might progress into 82 degrees during the day and 70 degrees at night and continue to ramp on down. So originally your difference between day and night might be 5 degrees, and then it's 10, 12, and probably maxing out around 15 degrees difference by the time you end flower, and at both significantly cooler temperatures. During this transition of temperatures, you also want to slowly ramp up the VPD. And you might actually be moving a little bit outside of the zone that plants love the most just for pure physiology and growth. But you have to counterbalance this with the risks for different types of mold. So we really want to ramp up the VPD as flower goes on and the temperatures get cooler. You might be targeting as high as 1.4 by the end of flower. And to do this, you're going to need to drop your humidity pretty significantly, especially as the temperatures come down. So when you're going through week by week and you're trying to plan out what humidity you need to have to hit a certain VPD, the best way to do that is to look at a VPD chart. And we have one in our grow guide and our product guide that you can look at, and you can see for any given target temperature, what humidity is required to hit your target VPD. That makes it really easy to go step by step and sort of make a plan about what temperatures you're going to hit, what the required humidity levels will be to hit your target VPD at those temperatures. And you can make a whole template going out through the end of the cycle. I think it's also important, if you understand the constraints of your environmental control system, to let that inform the strategy that you choose. We give some recommended levels from week to week for different VPD levels, but those are going to be just a starting point. You have to adjust everything for your particular facility, the strain, and especially the equipment that you have and what remains within that equipment's capacity for control.